This video is going to cover Unit 28, Section 3, Computing Heights and Bases of Prisms and Cylinders. The height of a prism or a cylinder can be found if the volume is known and the base is known. Also, at the same time, the base can be found if the volume is known and the height is known. So basically, we have the formula that we've covered before. Volume is equal to base times height. And all we're really doing is solving it for height by dividing both sides by b. Dividing by b. So the height is equal to the volume divided by the base. At the same time, we can say that the base is equal to the volume divided by the height. So here's our three equations dealing with volume, base, and height. So if we have the volume and the base, we can find the height. If we have the volume and the height, we can find the base. And of course, if we have the base and the height, we can find the volume. So it depends on which two you're given, you can find the other. So let's take a look at the example at the bottom of page 708, figure 28-18. So we have the base of this figure is a trapezoid. And it goes back. Something like that. Is that any good? It probably sucks. But at any rate, so this distance from here to here is 4 feet 0 inches, so 4. This distance from here to here is 6 feet 0 inches. And the distance from here to here is 2. This is what we're looking for. Right here. Question mark. That would be the height. So the base of this is going to be, so let's write that. Remember the area of a trapezoid is equal to base 1, 2, plus base 2, 4 in this case, divided by 2 times the height, which in this case is 6. So 6 divided by 2 is 3. 3 times 6 is 18. So the area of this base right here, this part right here, is 18 square feet. Now the volume, I think they give us, find the length, what can be constructed, 50. So the volume we know already as 50 yards cubed. Okay, so now this, in order for us to find this height right here, we have to use the equation right here. Okay, so height is equal to volume divided by base. Well, we have a little bit of a problem right now in that this unit on this is, it's feet. I don't know why I want to keep putting inches. It's feet squared. So this is in feet and this is in yards, cubic yards. So we need to know how many we either need to convert this to cubic feet or this into square yards, one way or the other, and it doesn't really matter which way you go. So let's find out. We need to find something out here. How many cubic feet are in a cubic yard? So what we can do here is let's take a look. I hope everybody knows, if you don't, you're going to know now, that 1 yard is 3 feet. And so what I'm doing here is if this is 1 yard from here to here, it's 3 feet. If this is a yard from here to here, it's 3 feet. So 1 square yard is 3 times 3. That's 9 square feet. Now we have to go up another unit right here. So 3. So we've got a volume here. 3 times 3 times 3. So 1, let's write it right here. 1 yard cubed is equal to 3 times 3 times 3, which is 27. 27 feet cubed. Okay? So that's our conversion right here. So what I'm going to do is convert, let's see, what do we... Let's convert this into cubic feet. That way we'll have the same units. We can't run these through this equation right here. Well, you can, but you'll get the wrong answer. We can't run these through this with saying that this is 50 and then divided by the base, which is 18, because the units don't match up. So we're going to change this into feet. So 50 yards cubed. Then I'm going to multiply that. Now I'll put a 1 under here just as a placeholder. So that should have been a D right there. Oops. So what I need here is, because yards is in the numerator, I need yards in the denominator. Yard cubed. So that means that feet cubed are in the top. So 1 yard cubed is the same thing as saying 27 feet cubed. This is a unit of 1. These are the same thing. I can't multiply this by anything other than 1, or I'll change its value. So, and I need to cross out the units. I set this up like this so that the units cancel that I don't want, and I don't want yards. And feet is what's left, feet cubed. So, then I just multiply across the top and across the bottom. Across the bottom I can see is just 1, so I'll just leave that. So the top is 50 times 27, which is, so the volume of this is 1350 feet cubed. So the numbers we need here are these. Now, because my units are in feet, when I put them through this equation right here, the unit that goes on the answer is going to be feet. So, let's see here. We got a little room right there. So, height is equal to volume divided by base. So, volume is 1350. I don't need to write feet cubed on that because I know it's feet. Everything is feet. Divided by 18. So 1350 divided by 18 is 75. So the height is equal to 75, and the unit that I put on there is feet. So this distance right here is equal to 75, and I'll use that unit there on that, because that's should have been putting those on there the whole time. Feet. Ta-da! So what we've done here is we've manipulated an equation to solve it for another variable. You can always do that. If you have an equation with several variables in it, you can always manipulate it to solve for one of the other variables. Okay, so we've done that, and then another thing that we've done in this lesson here is we've converted units from 1 unit, 50 yards cubed, to feet cubed, right there. And that's what I call that unit analysis. The idea here is to cancel out the units that you don't want, so the only units that are left are the ones that you want. This was a very quick one. We can do more elaborate ones than that, but that got rid of the yards and it converted it to feet cubed. So once I did the math, my answer was in cubic feet. That allows me to put that into the equation because the two units are the same. Like I said, you would not be able to accurately anyway put a 50 right there and an 18 right there, and you could do it mathematically, you could do it, but because the units aren't the same, your answer doesn't have any meaning.